In this video, we are going to talk about the short-run and long-run expansion path as it relates to producer theory. We have said before that we have an isoquant which shows all the combinations of capital and labor that give you the same amount of output. Now, if we are looking at the input prices, then we are going to find a point which is tangent to an isoquant, okay, and this line here is called the isocost line. And then the optimal production is occurring at this point here, where the isocost line is tangent to the isoquant line. Now, think about that the firm has decided to produce here, and that for some reason they are locked into the amount of capital they have picked here. So let's call this K bar. So what this means is that if K or capital is fixed in the short run, that means that if they have to expand production, they always have to use the same amount K star. So this line here would represent the short run expansion path. Now, if there is an increase in the quantity that needs to be produced, and suppose that we are now going to be on a higher isoquant, so consider this to be, for example, this isoquant here is associated with, say, Q equals 1, and let's keep it simple and assume that this isoquant here is Q equals 2. Okay. Then, since the firm has to use the amount K star in the short run, it is possible that since we are now having a parallel shift, the input prices do not change, we now have a parallel shift, that now the production at this point is not optimal, in the sense that since K is fixed, or capital is fixed, the point here is not tangent, or the slope of the isoquant line is not tangent with the isocost line. And only in the long run, when the firm can actually adjust the capital as well, or the fixed input, they can reduce their cost by moving from this point here to this point that is now satisfying the optimality condition of the isocost line being tangent to the isoquant line. Now, if we were to trace out all the points that are optimal in terms of tangency between the isocost line and the isoquant line, then we are going to get the long run expansion path. So this may look like, in this case, may look like something like this. And so here we have the long run expansion path. Okay. Now here I have the same graph as before. However, this is drawn with real values and with a computer, so it makes it a little bit more accurate. So as before, we have the initial point of production, which we are marking here, and assume that capital is fixed at this point, K star. So this line here again is the short run expansion path, since capital cannot be adjusted, and this part here is the long run expansion path. So if the firm has to switch from the isoquant that is associated with a lower production quantity to an isoquant that is associated with a higher production quantity. In the short run, they have to move from this point to this point, which is not optimal since the slope or the marginal rate of technical substitution, which is the slope of the isoquant line, is not tangent to the isocost line. And only in the long run, the firm can reduce their cost if they're moving to this point here. Okay, so in this case, they would be expanding in the short run. They would be expanding their production, and they would do so by increasing labor. And in the long run, they to sustain this increased production, they would reduce labor and increase capital. And so this is the explanation of the short run and long run expansion path.